Okay, so in this question, we've been asked to use the factor theorem to show that x plus 3 is a factor of f of x. So the factor theorem says that if f of a equals 0, then that means that x minus a is a factor. So that's what we're using here. So all we need to do is to substitute minus 3 into our function and show that it equals 0. So f of minus 3 will be minus 3 cubed plus 4 times minus 3 squared plus 11 times minus 3 minus 30. And if we substitute that in and do that on our calculator, we get 0, which is what we wanted. So we can then say, therefore, x plus 3 is a factor. So that's part A of that question done. Part B, we need to write f of x in this form. So we are going to do a little bit of division here. We're going to divide our minus x cubed plus 4x squared plus 11x minus 30, and we're going to divide all of that by x plus 3, because we know that x plus 3 is a factor from part A of the question. So x into minus x cubed goes minus x squared times. I'm now going to multiply this out. So minus x squared times x is minus x cubed. Minus x squared times 3 is minus 3x squared. And I'm going to take that away. The x cubes cancel out. And then I've got 4x squared minus minus, so that's a plus. So I get 7x squared. The 11x take away 0 is 11x. And the 30 take away 0 is 30. Right, I'm now going to repeat the process. Use a different colour for that. Right, x into 7x squared goes 7x times. Multiply that out. 7x times x is 7x squared. 7x times 3 is 21x. And we're going to take that away. The 7x squareds cancel out. The 11x take away 21x is minus 10x. The minus 30 take away 0 is minus 30. And then we're going to repeat the process one last time. X into minus 10x goes minus 10 times. And multiply that out. Minus 10 times x is minus 10x. Minus 10 times 3 is minus 30. And when we take those away, we get 0, which is what we expected, because x plus 3 is a factor. So that allows us now to rewrite our f of x as being x plus 3 times minus x squared plus 7x minus 10. So that's part B of this question done. So I'm just going to create a little bit more space for me here so I can now do parts C, D and E. So let me just get rid of all of that. Oops, too much. Right, that'll be fine. So part C of this question says, hence factorize f of x completely. So I know f of x currently looks like this. But I need to factorize it completely. So basically I need to do something with this. To help me with that, I don't like this minus at the front here. I don't like the minus x squared. So what I'm going to do is I'm going to factorize a minus outside of this just to make my life a little bit easier. So if I factorise a minus outside of this whole thing, that will make this become a plus x squared. This will become a minus 7x, and this will become a plus 10. And that's useful then because I've got this quadratic that can then be factorised easily into an x minus 2 and an x minus 5. So there we go. That is part C of this question done. We have factorised this quadratic completely and got this. Right, part D. Again, let me create a bit more space and hopefully not rub out the question. Part D. Hence, determine the x coordinates where the curve intersects on the x-axis. So basically these coordinates here. Well, I know that it intersects on the x-axis when y equals 0. And I have been able to write y in this form here. So basically, when does that equal 0? And I can see from my factorised form that it's going to be either minus 3, 2, or 5. So I know that this coordinate here is minus 3, this coordinate here is 2, this coordinate here is 5. And finally, part E, hence determine the area shown on the sketch. So I need to work out this area here, basically. So because I've got a part of the graph here that's below the x-axis and a part of the graph that's above the x-axis, I need to determine them separately and then add them together afterwards. So let me label these up. Let me call this one here A and this one here B. So let's work out the area of A first of all. That's going to be the integral from minus 3 to 2. Minus 3 is my lower limit, 2 is my upper limit, of my function x cubed plus 4x squared plus 11x minus 30 with respect to x. So I'm going to integrate this. So integrating the minus x cubed, so it'll become a power of 4 now, and I will have a minus 1/4 at the front. So that's just adding 1 to the power of 3 and dividing by 4. The 4x squared, so add 1 to the power to get cubed, divide by 3. The 11x will become 11x squared over 2. And the minus 30x, or sorry, the minus 30 will just become minus 30x. Then I'm going to substitute each of my limits in. So that's going to be equal to, so first of all, let's substitute the 2 into that. So I'll get minus 1/4, 2 to the power 4, plus 4 over 3, 2 to the power 3, plus 11 over 2, 2 squared, minus 30 times 2. So that's substituting the 2 in. I'm then going to take away what happens when I substitute the 3 in. So I'll get minus 1/4 times minus 3 to the power 4, plus 4 over 3, minus 3 to the power 3, plus 11 over 2 minus 3 squared, minus 30 times minus 3. So when I type all of that into my calculator, I'm not actually going to do this now because it's just a waste of video time me typing numbers into a calculator. But when you type all of that in, you will get some number. Just be really, really careful with all of those brackets. Do it very, very carefully, because obviously the brackets are very careful, especially very important, especially with all these negatives involved. So you'll get your answer on your calculator from this. Then we know that that area is going to be a negative because it's below the x-axis. So I know that this is a negative. So if you've done this on your calculator and got a positive answer, then you've typed something in wrong. We know it's going to be a negative number because it's below the x-axis here. So because of that, whatever number you get here, whatever negative number you get here, you just turn it to be a positive. So just get rid of that negative number, because if we're talking about an area, I don't care about the fact that it's below the axis at the moment. I'm just going to make it a positive number because I want my area to be positive. That then gives you the area of A. Then, to finish this question off, we need to work out the area of B. So, all I'm going to do then, let me correct this. To get the area of B, B is going to be the integral of the same function, because it's still the same curve. But now my limits are 2, that's my lower limit here, and 5, my upper limit there. Those are the limits for B. But then basically you just do exactly the same process. Exactly the same as what I just did. You integrate it and it'll be the same value. You substitute the 5 in. You then substitute the 2 in. You get your answers. We'll get a number here from our calculator. We know it's going to be a positive value because the B is above the x-axis here, so we don't need to worry about flipping the sign or anything like that. Then all you need to do to get your final answer is just add your area for A and B together. And that's it.